today. Tomorrow we'll have examination in the afternoon. Examination is for all, right? Those are registered. So 60 marks, right? For all those are registered without grade, and with grade I think 10 to 15 people have registered. For them the exam is for 100 marks. Got the point or not? So exams are those are registered. So we have registered, they must write the exam, right? So for all you are registered without grade, you need to write the test. So in the afternoon we'll have examination, and then there will be concluding session after the examination. In that we'll have validity, in that we are going to distribute the certificates, and then we'll try to take the feedback from the participants. Right. So tomorrow we are going to conclude this program, and meanwhile, as far as today's program is concerned, today Professor Michael is going to deliver one lecture in the morning, and then start with Professor Michael lecture on the energy storage today, and followed by the lectures by Raghavendra in the morning session. And today there will be special dinner in the same mess. Right? So at 7:30, the Ganga mess where you are dining your lunch break class or dinner. Okay, thank you. And similarly, you try to give your names exactly. So that will be, we are going to write on the certificate. Later there should not be any issue. You check the spellings, initials, your insured affiliation, everything, right? By afternoon you need to get it, because tomorrow you need to distribute the certificates. So if you give your names and affiliation correctly, then it is easy for us. It is not possible to change one second. So I request to coordinate and cooperate with the organizers, right?
Batteries is necessary to use very rare, not rare earths, but very rare and expensive materials like lithium. Scientific populity focus their attention and power into exchange lithium by another elements, more accessible. It is a great problem because, as we remember from previous days, many elements is difficult to exchange. like heavy elements in solar cells, like heavy elements and hazardous in nonlinear optics, and some hazardous elements the same lead in solar cells. It is a great problem that we have a very good solution, but its application in macro scale is very difficult and very expensive. And now we have a following situation that have overproduction of electricity from solar cells farm, but we not able collect as such, because it's one of human activity in world, not only physicists but also people working in measurement, in informatics, thinking about system of distribution. And the most cheapest solution appear when we preparate or produce energy we use on the same place, on site. And for example, when we have on roof house solar panels, it will be interesting use such energy to supply our house. But like we discussed previously, lighting is when sun not working. When it's for example, in my place, here is dark, but energy is needed. And from such point of view, it's necessary to make some storage system. And it's a many interesting solution. I told about afternoon about it, but it's some unconventional solution, and due to improving technology, a solution or discoveries which were less useful many years ago, at present time are more accessible and more useful. It is especially focused with achievements in material science, especially in production of ultra-thin films. And for example, when we have a parallel capacitor, capacity is proportional to area of capacity and proportional to d, distance between plates. When we decreasing such distance 10 times, the same capacitor possesses the 10 times higher energy collected inside. But it is another problem with connected with the electric permittivity of material between electrodes, because for vacuum is or for air is one and a little bit more, but for example, when we able to put inside material with epsilon 10, we also have opportunity not changing dimension, increase storage energy, and 10 times here, 10 times with the electric constant, and 100. It is some opportunities how do it. But it's a great problem with find such kind of materials because when we have a small distance, we have opportunity short currents appear, and it is destroying system. But I would like told you about some recent achievements in capacitor materials, because for capacitor is one of topic which is currently to discover is explored, because people, scientists and engineers see possibilities, especially with a fast charging system. And for example, it exists some transporting system when between bus stop, when bus stop charge condensator, capacitor, and broadcasting energy do a drive to next station. And it is a short introduction to today's talk. But we have many system for energy collecting. We have a traditional thermal energy storage. It is also important. For example, in our climate, I have maybe in my house a big tank for water, and utilizing sun energy, maybe directly or indirectly, utilizing, for example, photovoltaics. I can heating a system when it's good isolated. I may use such reservoir of water for heating, for example. It is one of a method for collecting energy. It's a thermal energy. It's also interesting that, for example, when we have a sun evaporation, when we have a wall covered a special film, not film, it is a wall additional, which collecting sun energy, absorbing, but is preventing to broadcasting outside, because it is like membrane, for one direction is passing, second is forbidden, and we have a collected energy for a future. It is a many system for collecting energy. For example, some furnace. Some furnace which have elements with high thermal storage, high energy storage, and we, for example, utilizing photovoltaic electric power, we heating in day, but slowly use such energy cooling and heating house during night. It is many system, because I more told about such influence and flow between a different kind of energy. I explain tomorrow, but today I would like to focus firstly on storage energy in form of capacitor. We have some different system. For example, chemical energy storage. It is fuel cells, hydrogen storage, ammonia storage, biofuel storage, alumina storage, and mechanical energy. Professor Kolenga is expert of mechanics, and he told when we have, for example, a rotating well, it is difficult to stop them. It is a rotational energy. It is a many system for for collecting energy, but it's a problem connected with efficiency of storage, because when we input 100% of energy, for example, we able to back 70, 90, because some energy maybe disappear during storage system, storage time, and also for transmitting with or transforming with one form to second. And electrochemical energy storage system. I told the battery. With batteries, we have a problem with lithium, because lithium is mostly located in China, Ukraine, and South America. You know such information when U.S. government like collaborate with Ukraine regarding lithium sources. It is important. But chemists, physics, engineering, thinking how exchange such material for another. And for example, for sodium, it is a close, but not the same. It is great advantages. And for example, we have a different application of storage system. When we have car, electric car, is important efficiency of collecting energy per mass. And when you have a phone, when you have a watch, it is very important. But for example, when we have nearly house a battery, stationary, big battery for collecting or storage electrical energy from our parent, it is not important if a weight of battery is 3 tons or 1 ton, because they bring and stay, for example, 8-10 years. But it's important expenses. It is how it's expensive phenomena. And from some kind of a calculation, when we try to storage the same energy in sodium or lithium batteries, we should for components to production pay almost 10 times less in situation when we consider sodium battery and in opposite to lithium battery. And next situation that such sodium battery may be more heavy, but for some proposals like I told for stationary utilizing, it is not important parameter. Price is most important. Now, I don't know like is in India, but in my country, storage system is 2-3 times more expensive in photovoltaic installation. It is for present, it is a great problem, and it is one of challenge for scientists. But also when we try to obtain, and what is it also a problem with charging, because batteries, I told later, have some disadvantages. Some disadvantages is a time of charging. For example, you hear we can charge very fast the battery in car. It is possible, but we don't know it is interesting from economic point of view, because when we charging battery with high energy. It is 50, 120 kilovolts. It is dangerous for life of battery. When we use a home system with a charging battery with a lower speed, our battery will be live 2-3 times longer. It is also important. And for example, when we should utilizing a system for fast charging batteries, we need a special line, a special equipment, and 1 kilowatt hour of energy, maybe 2-3 times higher when we pay for energy from taken from home installation. It is some advantages and disadvantages. It is a great many problems to solve. But one of another proposition, except battery, are capacitors. And now I start to talk about capacitors. Yes, we can divide such electricity energy storage for batteries and capacitors. Several few dozen years ago was discovered and patented so-called supercapacitors. It is different phenomena for such storing energy in ordinary capacitors, but also we have some version of capacitors, and just moment I focus on such group of materials. And here is some advantages and disadvantages of different kind of batteries, but it will be our topic later. Also, as I told, hydrogen storage. It is a great challenge for solve some problem with storage, because we discussed about water splitting. And for example, when we have such hydrogen, it's necessary storage them and using, taking account safety. It is a great problem which decreasing speed of application of such materials, especially for in cars. As I told early, we have a very simple system. Such system is quite cheap, not need maintenance, and have a long time for without problem utilizing as such. When I was a child, we sometimes destroying our radio system before Second World War. After 30 years of not using such system, we have some time with problem because capacitor still working. And as I told, it is a very simple formula and very simple way to improve capacity of such element. It is a very similar situation like in thermoelectrics. We have two elements like surface, but it is belong to our needs. We have maybe choose a bigger surface or lower, but it is two elements. It is connected with together. It is the electric permittivity and the distance between plates. And from such point of view, we should increase such parameters and also make opportunity to put plates close. And now we have some achievements in technology or solid dielectrics, which possess good dielectric properties, and we can improve such system. And as I told, 50 years ago, yes? 50 years ago. It is 50 years ago was introduced to market a so-called supercapacitor by a Japan company, which extremely high energy power output, and with a high charge density and life more than 10 years. It is very good, but also is important that 500,000 times life cycle is important, because a capacitor, in opposite to battery, is very frequently charges and discharges. And it is a two parameters which able to evaluate by consumer, and quality of system. It is a specified energy density. It is energy collected by capacitor divided by mass, and also power density, but the power density is connected with a source of which is supplied by energy. It is resistivity of source. But regarding physical phenomena which is applied, we have a so-called traditional electrostatic capacitors, so-called electrolytic, and electrochemical double layer system. And here, as you see, is many way how improving such materials, changing so-called area between electrodes. It is for traditional capacitor was a vacuum, no vacuum air. But here we have some nanocomposite materials. In next slide, I will discuss about such topics. And also, it is important to avoid about erosion, because when we have electrochemical active elements like is so-called electrolyte inside, it interact with electrodes, and some so-called generally called corrosion process may be a risk, and it will be decreasing lifetime of device. Here we have a description regarding physical background of a supercapacitor. They able working in as electrochemical storage, and utilizing both typical Faraday, it is for classical capacitors technology, and so-called reservoir redox reaction, it is typical for batteries. And so-called hybrid supercapacitors, which with both working Faraday and non-Faraday system, and so-called electric double layer capacitors when is charge stored at electrolyte interface. It is, as you see, elements, materials used for elements. We have many way to improving properties such materials, utilizing current material science achievements and expertise in different topics. Here is some information regarding such kind capacitors with a comparison or crucial information regarding working a such system. And for example, first, electrical double layer capacitor have a very high or possess very high cycling stability. It is also important for a particular application, and also possess a power density high, but energy density is quite low. What does it mean? We have a very good storage system, but heavy. And when we consider a possible application of such system, we also take account parameters, crucial key parameters for such application. Yes, and supercapacitors can be used in so-called two modes. One, when we require constant voltage, and second when is we prefer a constant current. It is connected with a charging method, but for discharge we have a free system, free opportunities, and constant resistance, constant current, and constant power. And for example, when we utilizing such car in car, for example, may be interesting to utilizing a tiered opportunity. But general, we can smoothly go from one to second or third method of discharging system. And as you remember from foundation of physics, here is some equation regarding changing of change of voltage during discharging capacitor. Here is a 0.99 not 1 because we consider that it capacitor not be fully discharged. And here, when we solve such a system equation, we can calculate with above system how changing in time voltage, how changing current, and how changing and discharging or charging time. Here is some interesting formula. It is possible to calculate capacity and another properties of capacitor to match with our needs. Here is a graphic a version of such a solution when so how changing in time voltage and changing current during a process charging discharging. And here we are able to see difference between charging and discharging battery and capacitor. And you see that is quite different. I'm sorry that not put a scale of time, because a time of charging, discharging battery is significantly longer, and for particular application may be interested to consider which kind of energy storage we need. And now we can focus our attention on some elements of condensator, and especially focusing on kind of used materials. And we have some kind of some groups of materials is so-called electrode materials. It is also important. I told about some problems with connected with a long time application and processes with connected with erosion, corrosion of such materials. Next is important is electrolyte materials and such separator between side of capacitor and collector materials and binder and constructive and conductive materials. It is also important because it must